Raw material extraction, principles of quarrying in the cement industry. Objectives and tasks for this video. Watch carefully the complete video. Remember that you can pause anytime and go back to see again the sequences which you may have not understood. At the end of the video, you will be able to discuss with your supervisor and answer the following questions. Why is it important to run the quarry effectively? What are the three main reasons for having to drill and blast in the quarry? What are the cost drivers of running a quarry? Why are quarry access roads so wide? What is a quarry? Quarry is a place, typically a large, deep pit, from which stone or other materials are extracted. Quarries can be open pit or underground. Most cement plants have open pit quarries. You see on this other picture another ground quarry. Importance of quarry performance. Quarries are the first initial step in the cement manufacturing process. They must be well operated since the raw materials are about 15% of the cost of cement. And remember that without raw materials, the kiln will have to be stopped. Performance and sustainability of the quarry means increasing quarry life through proper consumption of all existing materials in the quarry. This means that the best and the worst qualities of material should be utilized in the process. Let us look at the different phases involved in the quarry process. The first block, site preparation, is primarily done when opening up a new quarry. It is about planning the proper access roads, seeing that we do not interfere with villages or members of the public. Stripping and preserving topsoil means removing the layer of organic material where trees and bushes grow. Ideally, this soil should be preserved for later times when closing down and rehabilitating the quarry. This site preparation phase is not discussed in the current video. We will start discussing the phase about extracting, which is the most commonly done through blasting in the cement industry. But when and why do we have to drill and blast? We must drill and blast when dealing with hard rocks, otherwise it will be difficult to transport the material, it will not fit in the crusher, the grinding process will take much longer and consume a lot of electrical energy. There are few factors affecting drilling and blasting, mainly the safety precautions you have to take, which may, for example, force you to place the drilling machine in a different position than what you would ideally select. The production requirements, such as quarrying different materials to fulfill a specific raw mill design for special clinker. The geology factors, such as rock hardness, the slope of stratification of the material, caves and fractures in the different layers of material in the deposit. The bench geometry, its width, height. The equipment capability, how deep can the drill rods reach? The expertise of your personnel on site. They may have limited knowledge and know only one or a few methods for designing the drill process. And finally, vibration and air blast. These are negative side effects of the blast procedure. We will deal with the topic later on in the video. Remember that blasting is a dangerous exercise and safety precautions must be taken at all times. In the quarry you need good planning and communication, safety PPE, reflective vest, boots, hard hat and safety glasses. Cordon off the blast area and post signs indicating the risks, sirens and flashing lights, indicate when the blast is imminent, announce end of blast. Yes, it is crucial to inform everyone, employees and possible members of the public, which may be nearby, that the procedure is over and there is no more danger. We are all conscious that running costs drive the success or failure of a company. The main indicator for expenditure in the drilling process is the so-called powder factor, which, simplifying, means how many kilograms of explosives are needed to blast so many tons of material. The graph shows an example for given rock and explosives conditions. Using very little explosive, around 310 grams per ton, will be quite expensive, around €1 per ton. This is because with little explosive, the degree of rock fragmentations will be lower and secondary breakage will be needed to handle the rock and materials. Increasing the kilogram per ton of explosive will optimize costs to a point. When using more explosive doesn't improve the tonnage produced, just increases the overall cost of explosives, say above 450 grams per ton of explosive. We must also remember that blasting is the cheapest way to break rock. Bench geometry and powder factor are key components of cost. Study total mining and comminution cost to understand effects of blasting. This means including in the study the total cost generated after quarrying, for instance in crushing and grinding, depending on the size of the rocks and material provided to these stages. Site preparation is about getting ready to start drilling. The drilling accuracy is an important predictor of blasting success. Benches must be smooth and flat. There should be enough room for the trucks and machines to be placed where needed. Of course, safety of our workers is most important. And finally, let us make sure that the equipment is also protected and will not suffer damages in the process. Here are a few definitions used in the terminology of quarries when referring to drilling and blasting. Notice that in most cement companies, the quarry face is always at an angle, never vertical. This is of course for safety reasons to avoid sudden collapse of the top bench when machines and people are preparing for drilling. The maximum bench height, H, is normally limited by safety governmental offices. In many countries, say in Europe, this is limited to 12 meters. The drill hole with a diameter of D, depending on the type of drilling machine, will also be at the same inclined angle of the bench face. The holes are sub-drilled, going below the level of the lower bench, to make sure there is enough energy in the blast to push the material away from the new face and avoid the so-called toe as shown in the drawing. There are several possible patterns to drill holes as shown, typically in 2 or more rows parallel to the quarry face. Notice there are numbers for each one of these drill holes. They correspond to the sequence and timing of the blasting. The difference in timing between these numbers is only a few milliseconds, from 20 to 150 milliseconds, depending on the explosive used, rock hardness, conditions, and others. As mentioned earlier, the accuracy of the drilling location will influence the effectiveness of the blasting. Nowadays, drilling with GPS-equipped machines are preferable and less time-consuming than when locating by hand. These elements relate to open-face quarries. Even though higher benches provide generally cheaper solutions, as mentioned, government safety agencies limit the height for safety reasons. In lower benches, there is as well less risk of deviations in drill holes. The graph shows typical dimensions used as rule of thumb for planning drill holes. Notice there is a 0.9 meter of sub-drill for a 10.6 meter bench height. There is a 8.2 meters of high and low explosive and 2.5 meters of stemming of material used to retain the energy of the blast in the hole and forcing the gases resulting from the explosion to push the burden of the quarry phase. Start with rule of thumb, modify based on experiences made and results achieved, consider weight of explosive used. This will change the ratio of explosive versus stemming. Average powder factor for limestone is 0.22 kg per ton. This value is key information to calculate how much explosive will be needed for your next blasting project. Drill row by row for most efficient and reduced movements of the drill machine. Take samples to be analyzed. These will provide precise indication of the quality of material resulting from the blast. This short sequence shows how a new drill hole is started. You can see the drill bit starting to turn. Then the protecting skirt is lowered to retain material, avoid excessive dust emission, and collect the fines, which should also be taken for quality analysis. The operator lifts the rod while blowing compressed air to remove the cuttings from the drill hole. Always consider safety first. Whenever possible, use bulk trucks to deliver explosive, AMFO, ammonium nitrate and fuel oil, basically fertilizers mixed with diesel. Blast as soon as possible after loading. The sequence shows the complete procedure for loading a drill hole with explosive. The first step is to drop a bag or two of emulsified ammonium nitrate in the hole. This is an ignition accelerator to make sure the hole is free to the end and there will be some explosive in the sub-drill area. Then the operator is preparing the blasting cap. This is the silver rod connected to the yellow wire. This will ignite the shot, mainly the red TNT cap. He passes it through the TNT and inserts it back into it to make sure it will not come off. He then drops the cap and blasting cap in the hole, making sure it reaches the very bottom. The yellow wire is a so-called shock tube detonator, or non-explosive fuse or initiator, in short, the non-nail detonator. He then drops a few more bags of emulsified ammonium nitrate, cutting them open to make sure they fill up all cavities in the hole and around the TNT and blasting cap. He measures the free depth of the hole to know when the AMFO can be poured in with a truck. The operator is measuring continuously to monitor how much explosive is discharged in the hole. AMFO is a tertiary explosive, meaning that it cannot be set off by the small quantity of primary explosive in a typical blasting cap and will need the emulsified ammonium nitrate in the white bags. When the amount of explosive is reached, the holes are filled up with the leftover of cuttings from the drill machine. This is called stemming. the nonel detonators are connected to delays following a predefined pattern. Delay patterns will improve breakage and reduce vibration. And finally, clear, shoot, although this video shows an up-close look at the blasting process, never go near an active surface mine or blast site. The blast sequence follows 3 steps: initiation, blasting, fragmentation. Initial compression caused by detonation. At this point, the detonation creates gases which fracture the rock. The inertia and mass of the material reflects the pressure waves, and this is when the expanding gases push off the material towards the least resistant side, the quarry face. At this stage, the collapse of the quarry face also produces secondary fragmentation of the material falling onto itself. Secondary breakage may be necessary whenever large rocks remain after the blast. This can be done through secondary blasting or using a drop ball or a rock hammer. Presence of such large rocks indicates that the blasting was not successful, in most cases due to insufficient usage of explosives for the blast. In the sequence, the operator drills a hole in the rock and a piece of TNT fitted with a detonator will be used to break down the rock. One of the dangers from the blasting procedure is the generation of so-called fly rocks. There are well-known reasons causing fly rock, mainly overcharge and or understamped holes, out-of-sequence hole, the second hole is detonated before the first one, underburdened quarry face, the fly rocks can go very far away, easily a few hundred meters, and can be extremely dangerous. There are other ways to extracting raw materials, for instance through ripping or surface mining. Transportation of raw materials can be done using trucks, belt conveyors, barges, or rail. The usage of loaders and trucks is the most common method used because it is flexible and cost-effective. Different types of loaders and trucks are available to transport the raw material. Selection criteria for the most appropriate ones will depend on the material's characteristics, distances to be transported, local environment conditions, rain, snow, local suppliers, maintenance, and spare parts availability. Truck tires are exposed to harsh conditions in the quarry, with the presence of sharp limestone freshly blasted. Reduce costs with a tire maintenance program, always keeping the load and unloading areas clean and maintaining proper haul road conditions. Why are haul roads important? The graph shows the impact of different levels of rolling resistance of a loaded truck. At 2% resistance, the blue line, with a good road, travel time over 1.6 km will be around 2 minutes. For a rolling resistance of 8%, orange line, with poor road conditions, travel time more than double at about 4.3 minutes. An increase of 5% in rolling resistance will reduce overall production by 10% and increase production cost by 35%. Haul road construction and maintenance is key to ensure smooth operation of mobile equipment at the lowest possible costs. The haul road starts at the face and ends at the dump area. Haul road condition has a significant impact on cost of tires, fuel, and maintenance. Straight, even grades lower than 10% lead to better productivity. Constant vehicle speed means higher gearbox ratio and reduced fuel consumption. There are some best practices to remember in terms of haul road maintenance. For instance, keep ditches and water drains clear. Maintain road across total width. Perform monthly haul road evaluations. Consider use of stabilizers to reduce dust and preserve roads. Consider using local contractor, outsourcing. You have finished this video and you should now be able to answer these questions. Why is it important to run the quarry effectively? What are the three main reasons for having to drill and blast in the quarry? What are the cost drivers of running a quarry? Why are quarry access roads so wide? Thank you for your attention and looking forward to you participating to the next training video.